I'm going to go through these kind of quickly just so you can get them all, so you have time to submit them. But this is a study of 1,000 randomly selected flights of a major airline showed that 784 of the flights arrived on time. What is the probability that a randomly chosen flight did not arrive on time? So it's just going to be 1,000 minus all the ones that did arrive on time. So if we do 1,000 minus 784, we get what? Is that 216? So it's just going to be that number divided by the total number of flights. 216 divided by 1,000. They probably want you to reduce that. You can do that in your calculator if you have this nice calculator. You just do 216 divided by 1,000. Math, enter. 27 over 125. So this is 27 over 125. That's your first guy. Okay, the distribution of blood types for 1,000 Americans is listed in the table below. If one person selected at random, find the probability of selecting a person with O positive or O negative blood. That's just going to be these two added together over 1,000. So that's going to be 430 over 1,000, which is 43 over 100. Person who does not have B, is that B negative? That looks like B negative. Does not have B negative. If 20 people do have B negative, and there's 1,000 people, that means 9,980 people do not have B negative. Over 1,000. So we'll do 9980 divided by 1,000. Oops, divided by 1,000. Math. Enter. Oops, that's not right. I wanted I'm sorry, 998. My bad. Not 9,980. There you go. My brain's not working. There you go. 998 divided by 1,000. Math. Enter. There we go. 247 over 250. Okay. All right. At a local racetrack, the favorite horse has odds 2 to 3 of winning. What is the probability the horse wins the race? That means for every 2 times he'll win the race, he'll lose the race 3 times. So that's going to be out of 5 times total, he's going to win the race twice. 2 out of 5 times. Okay. All right. You roll 2 dice. What is the probability of getting the sum of more than 9? If you roll 2 dice, you can get any number from 2 to 36. Okay. So you can list out all the possibilities. So you could say like there's a sample space. I have it somewhere, but it's going to be you can get 10, 11, 12, so 10 through 36. Okay. Okay, so I just copied the sample set, the sample space. It's going to look like this. This is all the possibilities from rolling 2 die. Okay. So there's 36 possibilities. You're going to count up how many ways you can get more than 9. So these are all 7. This is all less than 8. So this is all 8. So this is 9. So none of these count. This is going to be 9. So this is more than 9. And then this, no. These are more than 9. And these are more than 9. So those are the only ways you can roll more than 9. So you have 1, 2, 3, 4, 5, 6 ways. So 6 out of 36 possibilities, or 1/6. At most 6. All right. Well, these are all. That's 2. So this all works. At most 6. So 6 or less. 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 There you go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of 36, which divide both of them by 3, you get 5 over 12. Okay, box of 20 calculators contains 3 broken calculators. You draw a sample of 2 calculators without replacement. Find the probability that both are broken. So the probability that the first one is broken is 3 out of 20. When you find the probability of the second thing, always assume you got what you wanted the first time. So we assume we took a broken calculator out. So how many are left? There's 2 calculators that are broken left. There are 19 calculators left. So now we're just going to multiply those together. You can do it all in the calculator. 3 divided by 20 times 2 divided by 19. Enter, math, enter. We get 3 over 190. Both calculators are not broken. Well, if there's 3 that are broken, there are 17 that are not broken. So probably the first one being not broken is 17 out of 20. And then we take a non-broken calculator out. So there are 16 non-broken left and 19 altogether. So this is going to be 17 divided by 20 times 16 divided by 19. We get math, enter. That's going to be 68 over 95. At least one calculator is broken. So that means one calculator is broken or 2 calculators are broken. Well, that's the same thing as saying the opposite of no calculator is broken. So this is the probability of no calculator is broken. The opposite is going to be at least one broken. So we can just take this guy and subtract it from 1. That's going to be 1 minus 68 over 95. So we get 1 minus, take my previous answer. And I get 27 over 95. Okay. Probability that a person in the United States has A positive blood is 34%. 2 unrelated citizens were chosen at random. Each trial is independent. What's the probability that both have A positive blood? Well, if the probability of the first one having A positive blood is 34%, and the probability of the second one having A positive blood is 34%, probability of both of them having it is just going to be 34% times 34%. As a decimal, I don't know how many decimal places they want, times 0.34. Is going to be 0.1156. Neither of them have A positive blood, so that's going to be the remaining percentage. So the probability of not A positive is going to be 66%, or 0.66 times 0.66. 0.4356. At least one has A positive blood. So if neither of them have A positive, the opposite of that is either at least one has A positive. Okay? So just like the last problem, I'm just going to take this answer and subtract it from 1. So I'll do 1 minus my previous answer. I get 0.5644. Are any of the events A, B, or C unusual? If yes, why? I don't know what his definition of unusual are. I don't think any of them are unusual because all of them have a probability of above 10%. So I would just say, I don't know, no. He doesn't give a standard as to why, if something's unusual or not. Maybe he mentioned that in class. If it's below a certain percentage, it's unusual, but that's subjective. So I'm not sure what he wants there. Survey found that 80% of adults own a cell phone. Of those, 30% use Verizon as a provider. One adult is selected at random. Find the probability that he or she has a cell phone and it's Verizon. So the probability that the person owns a cell phone is 80%. Okay. Of those, 30% use Verizon. So we want to figure out, all right, well, then what's the chance he uses Verizon? So it's 80% he has a phone times 30% that he uses Verizon. 80% times 30%. It's just going to be 20.24 or 24%. That's it. There's a 30% chance an obese person will have high cholesterol. The chance an obese person will have high glucose is 20%. The chance that an obese person has both high cholesterol and high glucose is 10%. What is the probability that an obese person selected at random has high cholesterol or high glucose? These are not mutually exclusive events. So the probability of something or something is going to be equal to the probability of the first thing plus the probability of the second thing minus the probability of both things. So the probability that the person has high cholesterol is 30%, so that's going to be 0.3 or 0.30, plus the probability the person has high glucose, which is 0.20, minus the probability that they have both, which is 0.10. This is 5 minus 1, that's going to be 0.40 or 0.4. Bar graph to the right shows types of incidents encountered by drivers using cell phones. Find the probability that a randomly chosen incident involved almost hitting a car. Almost hitting a car is 19, so it's going to be 19 over the total. Add these all up. What is that? 84, 104, 123, I think. 123 is prime, I believe, so I think that doesn't reduce. Yeah, you're good. Okay. You can always email me back with any questions. I know I'm going fast, but the distribution of master's degrees conferred by the Millersville University is listed below. What is the probability of a randomly selected graduate majored in engineering? That's just the number of engineering majors, 75 over the total. You have to add them up. 216 plus 207 plus 75 plus 176 plus 222. 896. So then we do 75 divided by 896. Math, enter. That's it, doesn't reduce. Not an education major. So there's 222 education majors. So not education majors is going to be 896 minus 222. It's going to be 764 divided by 896. Math, enter. 337 over 448. For social studies exam, a student must complete any 4 in order out of 6 essay questions. How many ways can the student make his or her choices? Must complete any 4 out of 6 essay questions. So the order in which they do the questions doesn't seem to matter. So this is going to be a combination because order doesn't matter. So this is just going to be 6, choose 4 things. In our calculator, we can do that. We're just going to do 6, go to math, probability, down to NCR, choose 4, and we get 15 possible ways. All right, I'll send the other problems in the next video.